Hi and welcome. This time around, we'll be taking a look at installing a power feed on the one remaining axis on my mill that doesn't have one, the Y-axis. You might have seen my previous videos in the past, or video singular, where I installed a power feed on the Z-axis of the mill. And that one went well, but you might be wondering then why am I doing another video? Well, number one, the Y-axis might be different. The Z-axis is a little bit different configuration, I think. And secondly, this is made in Taiwan. The previous one I installed was made in China, and I'm kind of curious to see what the differences are, and I thought maybe you would be too. It turns out, by total coincidence, I chose one on eBay that was made in Taiwan. This is the brand that Accra, where I bought my mill from, installed on the mill to begin with for my X-axis, which is the only axis that originally had a power feed. So let's get right in there. This is made in Taiwan, previous one made in China. Let's see if there's improvements on this guy. By the way, this unit was more expensive than the Chinese one, which makes sense, made in Taiwan. Here's the manual. We'll take a look at that in a second. Actually, there's two manuals with instructions and CAD drawings. That's kind of cool. I thought I'd unpack some of this stuff on the bench here just to see what it included. Here is the hardware in a separate box. That's a little bit different. The last one had the shaft like pre-installed with a bunch of hardware on it. This one, it's all separate. Interesting. The packaging inside the box, it is very well protected with cardboard. Another nice little detail. Really nice custom packaging to hold this thing in place for shipping, which has to be expensive. Here is the gear, the brass gear, and the other bits that are associated with it. This one's aluminum. I remember the last one was steel. This one is aluminum, or maybe you won't remember if you didn't watch the video. And the parts aren't pre-installed on this. Wow, they even have a plastic cover to protect the gear teeth. Nice, very nice. With silica gel to prevent corrosion, except that none of this really is subject to corrosion. That might have been. And here's the actual unit itself, which is very light and looks pretty darn well made. Also in the box were these rails for mounting the end stops for the power feed. Interestingly enough, on my X-axis, I've removed those stops because it's such a long feed, I never run close to the end, at least not normally. I can put them back on, they're just tie wrapped underneath the motor itself. With the Y-axis, I'm gonna put them on because if you run past the end and actually hit a stop, you can either damage your feed screw, or you could damage the motor. Probably that brass gear, the teeth would shear right off, I'm guessing, but don't know for sure. Let's take a look at the manual and the instructions. I like the fact they have CAD drawings here. It's got warnings about checking to make sure all these holes are exactly where you expect they are. Fortunately, I couldn't do that until I actually had this. Maybe I could have gone to Align's website and downloaded it. Oh, I see. Other side of the manual, flip it, and it's English. Really nice manual, by far better than the previous one. Look at that, like it. Installation instructions. All right, so it looks like the first step is going to be to remove this handle. I'm guessing like last time, hand wheel needs to come off. Oh, whole thing comes off. Hand wheel nut. I guess I could take this opportunity to clean it. Got lots of marks on it. So each, interestingly enough, you think this would be metric because these look like about 1 centimeter spacing, and there's 200 of them going around, but actually each increment is 1,000, so it's 200 thousandths per revolution, which I have seen before, which might very well be completely standard. All right. Then I believe this guy's got to come out and be replaced with the new one. They do not have step-by-step instructions, but I believe this guy comes out and is replaced by this guy, which will have the power feed mounting screw holes here and here. So I think that's what we're looking at here. So this piece comes off and gets replaced. Not super tight, so no problem there. These cheap Harbor Freight Allen wrenches, it's caught the Allen in the ball, and it was really hard to remove. I've had that happen before with these guys. That's plenty loose. Very good. There's the original piece. I'm guessing they're going to have their own screws. These are pretty short, but maybe not. Let's take a look real quick. Let's see. Oh, and the extension shaft has to go on as well. The extension shaft has its own key and a roll pin too. That's kind of curious. Okay, that's very different. All right, let me take one more look at the instructions, see what's going on there. But I think this should line up pretty well. Oh, would be, oh no, that's good. That's good right there, yeah. And that's a really good fit too. It's like right on the money. That's gonna be almost an interference fit when I tighten that down. Let's see. No, so I'm guessing there are other screws for this because so the kit did not come with longer screws, and this other one is much shallower. So you'll see that the screws protrude out of this one. Even though that's countersunk quite a ways, they do not stick out on this one. So I'm gonna have to find 3 more screws, which I have metric screws, fortunately. Hopefully I'll have the right ones. Every time I place an order in McMaster Car for parts for one of my projects, I also buy some spare screws every single time. And luckily I bought some metric cap head screws in just a couple sizes, and I lucked out that one of them, I think, was correct. Let's see, hopefully these won't bottom out or anything crazy like that. Feels like these will be correct. Yeah, they're tightening up. So that's good. On to the shaft extension. I guess I remember, I don't remember whether I had to drill that hole or not. That is a nice fitting key. All right. So I believe this guy goes on here, and this guy threads on here. That's quite a long extension. That is way out here now. Ah, now remember, well, maybe you won't remember. When I installed the Z-axis, I was saying, oh, you know, I could probably rotate this guy. This might fit with it in place, but they're really close to each other. I might end up rotating this over 1 notch so that it's out of the way of this guy. Next, this guy would go on, which they have a cap to protect the teeth of their bevel gear. Oh, that's interesting. That's why they have the short key. The short key goes back here. So, yeah, that makes sense. So there's 2 keys now. One up front for the hand wheel for this guy, so you can manually use it. And another one back here, so you obviously, so the brass key has something to grab onto. Oh. Okay, so I think we're gonna need shims behind this guy to push this out, because I can't get this to go in far enough. See, this part is sticking proud, which is keeping this gear off of that gear. So I think the shim is actually gonna need to go on the other side, because this doesn't engage. So the spacing that needs to increase is this spacing to push it forward so that this guy, who's sitting here like this now, yeah, now it engages. So I need to space this unit forward. All right, so I had to take everything back off. I was considering making a spacer between this guy and the power feed, which would serve my purposes. Or I could remove some length off of this guy because it was sticking too far forward. But when I took everything apart again, I found there were 3 shims inside. I needed about 36 thousandths off. This is 42 thousandths. So I think we're just going to remove those shims. Then this guy, when he goes back in, will end up being exactly the right thickness, I think. Now I can just reassemble everything I just took apart. As I recall, there's plenty of this in installing one of these. They're never exactly quite straightforward because they make them universal for all of the mills out there. And so it really depends on what mill you have, how well it's going to fit. Oh yeah, look at that. It's no longer sticking proud. Well, then I can use all the shims and now space the gear forward until I get it right. So now we can put these 2 screws back and then set the gear up so that it engages properly. Also, this guy could be rotated. Didn't even consider that option. So this one could either be rotated this way out of the way. However, this lever is still going to come across here and run into this handle. So maybe I need to rotate this one out of the way instead, which will make it a little less convenient to reach, but probably not horrible. Oh, however, that makes it so the other screw does not match. Look at that. Yeah, because they did not drill holes in these other 2, which would solve that problem. Oh, never mind. I think we're going to be okay. I was worried this handle was going to run into this, but it's curved enough that it should miss. Phew, that lucked out. Okay, so we need to figure out the number of shims now to get this guy to engage properly. So here in neutral, this thing spins freely. The gear's engaging so smoothly that I can barely feel that it's actually engaging. That's a difference between these two. I definitely could feel the gear grabbing on this one, so that's a difference for sure. Huh, that is a little grindy. I don't know what to expect, to be honest with you. All right, let's go back to just one of the medium thickness shims just to see what happens. Oh, okay, you can hear the difference, no grinding. All right, we're gonna go with that. All right, so next up, I think the next step is I have to tighten this guy. And on the other one, you're supposed to drill through the shaft, but I think I put a bit of Loctite, and that was good enough. I wonder if it'd be the same with this one. They want me to put a roll pin through the shaft, and I don't remember actually doing that. All right, I shortened the long key that came with the mill. I suppose in a pinch it would still work. Then this guy has to be short enough, so that key is now definitely short enough to not engage, so that's good. We'll set that aside for now because I have to figure out how to make this. I'm pretty sure I did not drill through, but maybe I did. It just kind of spooks me to want to put a roll pin right through the center of a perfectly good set of threads. Well, I've opted to put in the roll pin, not making me warm and fuzzy at all. And I think I'm going to go with a center drill second, drilling through the threads on the shaft of my mill. This does not give me a warm and fuzzy. All right, well that's good. Didn't permanently damage the threads. All right. So, how do you fit? Yeah, see, I knew the shaft was mating. This shaft is pretty precisely bored, and so it's running into just a little protrusion there. They should have made that roll pin undersized. That would have been handy. It's a little tight. Okay, there we go. Much better. Oh, that's the old one. That can stay with the old one. Okay. So I also see why this shaft is so long, because it needs to stick out far enough that this handle clears the motor. Okay. Oh, that grinding doesn't seem good. Maybe I need another shim on the inside there. So this is the whole procedure I went through last time. Off on, off on, off on. All right, there's a problem here. You see how this, I don't know if you can see this here, but when I go one direction, this whole shaft comes this direction. There's nothing holding it in place anymore. Oh yeah. So the whole shaft is coming this way. I don't know if you can see that last bit there as it tightens up. I wonder if this little relief piece here is not enough and it's not reaching, so I need a spacer between here and the bearings, or I need to turn this face down just a little bit to reveal some more of this internal part here, because I don't think it's pushing on the bearings the way it should. Or I could just make a spacer in there. I think that's what the issue is that this, although this looks very similar, oh, you can see there's a difference between here and the flat and here and the flat. This one, I'm gonna have to turn this guy down, I think, so that it keeps the bearings in place. That's my problem. All right, well, we got that sorted. All right, so I've got the face of this guy parallel. See my 6-jaw chuck here, we're within thousandth, which will be good enough. And we need to go 50 thousandths. We need to make this piece here that sticks out 50 thousandths more. So I need to remove 50 thousandths of material. So this says 98 thousandths. That's 98 thousandths. But the actual ring is about 160 thousandths. So we actually have 60 thousandths to come off. Let's try 30 thousandths. The interrupted cut you're hearing is all the screw holes. Here's 60 thousandths. A little undercut to deal with the radius there. And I think we should be good. Let's give it a measure. What this sort of means is if you don't have a lathe, you're kind of hosed. I guess if you have a mill, you probably have a lathe, but no guarantees, right? Now we should be able to hold those bearings in, solve our problem. All right, so let's get this guy back together. Now, hopefully, this part will reach in further and keep those bearings flush. And I made it just a tiny bit smaller, and it seems to be fitting a little more snugly. And I feel like I'm bottoming out now. Hopefully, I'm bottoming out on the bearings. All right, let's position here. Oops. I noticed the diameter of this piece was a bit higher than the other one, and I thought it was just fitting, but I don't think this is actually going in. I'm looking at the spacing. I don't think it actually goes in. I think I might have to turn this guy again. This diameter is slightly larger than this one by like 20 thousandths, and I thought it'd be okay, but apparently not. All right, so until you get this nut on the end pushing this whole assembly back, the whole shaft can screw out of the machine. So you can't test anything without that. You got to put it all together. So this piece back here that I machined so it would push against the bearing, once it started pushing on the bearing, we are good to go. And it doesn't matter which direction I go. We are now nice and solid, and it sounds good. All right, so just want to do a quick test here. And I don't have the limit stops here, so I've got to be careful to stay away from the limit. But just listening to this, it sounds a little grindy, so I think maybe I need another spacer on the inside, which just means taking all this apart again. I'm getting really good at it. I think this is the final test that kind of decides it, I think. So back apart again. So one concern I have here is that this manual handle, you can get your hand stuck in here, like right here. That is not good. Could break your finger. That would really hurt. Got to remember to keep your hand outside this thing. Either that or we need to space this thing out further so that a finger would fit in there. I don't think I can get that much of a gap though. There are more threads on this. Yeah, that's a problem adding spacers here. Which it came with this spacer. I don't think that's going to space it quite enough, but I'd need to have a keyway put in any washer that goes in there. Kind of forgot about that bit. Well, that gives it a little more. It is still possible. It's much harder to crush my fingers in here now. All right. I think we're good. All right, so now we just need to put in the stops. I would like to have this guy out of the way, but it turns out those extra holes, at least on this model, are not so that you can rotate it at an angle. I'd need to drill holes where there's casting marks, which looks like there could have been holes planned, but that didn't work. I also needed to modify this piece here so it would fit in enough to push on the bearings because the bearings were popping out, and that was my problem before. This is kind of tight together. I think it'll be okay for now, but I think we might need to do something more with that. All right, it's a very busy place where they want me to put the stops for this thing. They've got this bracket that comes in two pieces. One has got the two switches on it. The other one's this cast metal bit that just clamps right on here, which seems like, wow, that's really convenient, except that there is no room for the stops. So here's the bar where the stops would mount. And as you can see, there really isn't a lot of room here for this. And the limits, it actually needs to go all the way over here if it's going to stop. It would need to be, I don't think that can go up any further either. Yeah, it would actually need to be all the way over to here. That's one extreme of this guy. We're at the other extreme right now, more or less. There, you can see what I'm saying. Here's the stop at the other extreme. So there needs to be a stop just before here and all the way back there. I'm not quite sure how to pull this off. They did not make this as easy as I'd hoped they would. The other option is to mount this guy in the middle here and have something like this move back and forth, but I don't think that's going to work either. I did not think about this aspect. I just figured they'd already worked that out. Apparently not. So we're going to have to find some solution. Look at how far in that is. I mean, I guess I could put something that would mount on here that would just hit this stop before it got here, like about there. I don't want it to cut into this bit or even put a screw in this bit because that's where the Z-axis shaft goes. So that seems like a bad idea. I'm gonna have to think about this a bit before I figure out how to put the emergency stops or limit stops in here. All right, so the limit switch is upside down the way this thing mounts it, which is like this. You can't put it like this when this part is clamped on the bottom of the X-axis cross slide, this would be mounted like this, right? Okay, let me put this somewhere in the middle. So, if I was going this direction, this should stop, but it's this one that stops it. It's on the wrong side, and vice versa. That one stops it. So, the limit switch really needs to be this way, because this clamp holds this like this. I don't really understand what they were thinking. I can't see any, unless you meant to have it up this way, then it would be correct. But there's no room in there to do that. So you can't fit it like that. Maybe that works on other mills, not on mine, however. So what I'm gonna do is, I'm gonna modify this. Yeah, in order to have this up on mine, this part would be into the lead screw. So this is a cast part and there's draft. So what I'm gonna do is I'm gonna drill and tap a couple screw holes in here, but first I'm gonna flatten it off because you can't really see it easily, but there's draft from the mold, a lot of it. And so I want a flat surface to screw to, which means clamping this might be a little weird too. I'm kind of curious about how that's gonna work out. But yeah, we're gonna take a couple milling passes across here to flatten this out, drill and tap in the center of each of those sides. And then we're gonna take a piece of metal. This will be upside down. We're gonna make a piece of fairly thick flat stock that will hold this guy like this over here. And this stop is in the right direction now, just to verify. Here it is moving. See? Keeps going this way, runs into the stop. So that's the right direction. It's always the frickin' safety stuff or the damage prevention stuff that's the hardest to work on these things. The wires are in the way. It's hard to get these things configured right. Just a total pain. Anyways, we're gonna try and modify this guy and get him to work. All right, so we got this guy in the vise. We're gonna mill across here and get a flat set spot, and then we're gonna get put two holes in here, hopefully some sort of even spacing. And because this is a casting, there's actually draft on pretty much every side other than this one and this one. It seems this side was machined flat, and that one sort of is. This thing is mostly sitting in there flat, so we're gonna try and take a pass across here and clean this up. Did just discover while I was lowering the knee, definitely the stop is going to have to be mounted on the knee, so that changes the calculus a little bit. I was hoping to put it on the main column because it could be out of the way. Can't do that because when you raise the knee up and down, unless I have a long plate or something that it would run into, that's not going to work. So, I mean, could have a long plate, but I think that's a silly solution. So instead, we will mount it on the knee. The problem is where can I drill a hole where I won't potentially damage the knee? I don't want to get into the dovetail section. That's all not good. That's going pretty well. Looks like I might get this in one pass. That's nice. All right, so we're gonna drill and tap. This doesn't look like center, but I believe it actually is. I use center finder to find it. And now I'm hoping to find the other center some even distance away, like somewhere around here. 2.25, look at that. 2.25. By the way, did I mention that these are standard hardware, not metric hardware, even though it's from Taiwan? That was really surprising, I gotta say. All right, I think we got a starting hole. Slow this down a little bit. The fact that it came out the other hole made it really easy to tap all the way through. So that's cool. I've got a much too long extension arm. This is gonna bolt on here, and then the sensor is gonna bolt over here, or here, somewhere over here, and then I'll cut off the excess, because originally I'd planned to put it on the main column, but that's not gonna work unless I wanna have a bar going up and down the whole column. This doesn't make sense, so we're gonna see what we can do. Interestingly enough, I drilled right down the center and caught the center of these. So they planned 2 1/4. I figured it'd all be metric, but this is 2 1/4 spacing, which is kind of interesting. Okay, then I just need to have the mount for this guy, 5/16, and I need to figure out where exactly it's going to go. So I need to figure that out. I've got more than enough material. I've left extra, and so we can continue. All right, so we've got this guy mounted on here. We're going to end up making this shorter because it's not going to go where I originally thought. However, I do need to see what range I need to be interested in. All right, so after mounting this guy, now maybe you'll see what my intentions were here, because originally this guy would have been here. So we're close to one extreme here. I'm not even all the way over yet. And what you'll see is that if this was here, I'd have to mount something right on this round section here for the stop. Or I can't lower it down because it'll run into the oiler. I can't raise it up because there's no room to raise it up anymore without making a new bracket. And if I did, that wouldn't exactly solve my problem. It would partially solve my problem. Or I could screw this directly to this piece. But I was looking at this, and where this is attached here, it's only about, you know, about an inch thick going in and about a ½ inch thick this way. So about 1 inch by ½ inch. And I was worried about, you know, weakening my cross-side assembly. So I really wasn't too happy about that. So, oh, I didn't tighten. I didn't tighten this guy yet either. These are just finger tight. So once I tighten this, that'll be plenty stiff. The question is, where should this go? So this could go here, for example, and I could put a stop right here. The question is the other limit, which is sort of going to decide what I'm going to do here. However, in this direction, what I got to be careful of is not running out of table space so much as, like right now, my vise that you can barely see right here, this is the bottom of the vise. This sticks out the back just a little bit, and that is what's making it stop. So, you know, that's a problem. So this guy could be here. Nothing about this whole process has been as nice as I would have liked it. It's almost like my mill was they're never intending on having a Y-axis power feed, which I can see that. The most common power feed is just the X-axis, and that's what my mill came with by default. Z-axis is what I added because bringing the knee up and down is a real pain, and so that's been a real boon. Y-axis I've had to feed quite often, especially oftentimes when I'm just cutting along the edge of a part, just smoothing up the edges or cutting it to length. So it's really handy to have, and I do it manually, but I think it'll be a much smoother and cleaner finish if I do it with a power feed. All right, so I saved you all the drilling and tapping. I mounted this guy. I actually put 2 sets of holes so I could shift it 2 ways. I might actually move it that way a little, but that's for another time. I can play around with it. Right now I'm limited by my vise in the back, not actually table travel, so that's not quite the same thing. For the stops, I drilled a hole in a round piece of aluminum, and I drilled the hole off center. And here we are going towards the stop and stop. The other direction, this guy over here, same sort of thing. I really didn't like drilling a hole in my casting. What I was thinking about doing was gluing, epoxying an aluminum bar on there and drilling and tapping that. I was very tempted because I was too close to the dovetail, but I was able to get far enough over that I did it anyways, but I wasn't very comfortable with it. And stop. Perfect. And that's it. Well, to give you my thoughts, I think this new drive works fine. It's actually not any smoother than the A-Song as far as movement is concerned, which is a Chinese one. This was like $100 more than this, so this was more expensive. The gear came covered and protected, which was nice. The other one was just in a box, which, you know, protected it more or less. I don't know that I would exactly recommend this one over this one, to be honest with you. It wasn't enough better. And as a matter of fact, I had to modify this guy here so that it would fit in far enough to hit the bearing. Now, they obviously were thinking about a different mill, and maybe a Chinese one would have the same problem. Because, you know, you never know what the spacings are in all these mills, because they're all clones of the Bridgeport, and they all do their own thing to some degree. So I'm not exactly sure where to go with that. I think it's pretty decent and I'm happy with it, and I'm going to be glad to be able to have a Y-axis power feed. It'll make some of my milling operations probably smoother because, again, as you guys know, my hand-eye coordination is pretty mediocre. This one matches the one that I've been using for years over here on the X-axis, same brand, and it's been completely trouble-free. So I guess I have to say that it's reasonable and I don't have a problem with it, but it was more expensive, and so it may not be the cheapest solution that's adequate. Go with that. Anyways, thanks for watching. Hope you find it useful. Hope to see you next time.